Coming at you live tonight from the Hill household. Our topic tonight is probability. Now, we've all probably heard that word probability before, the probability that it's going to rain today or the likelihood that it might snow. So our goal is to investigate some probabilities that are going to be pretty common in our course. So first of all, the probability of an event is from 0 to 1. All right, so our answers have to fall in there, which means they're all going to be decimals unless they're 0 or 1 themselves. Notice I can't have a negative probability. And this just indicates the likelihood that an event will occur or not occur. Alright, so within that in mind, like I said, they have to fall between 0 and 1. So I'm going to scroll up a little here. Now, if it's 0, that's implying that this event will never happen. So, event will not happen. Okay, if your probability is 0. And again, it can't be negative. If it's 0, it's just not going to happen. Now, on the other end of the spectrum, if we get a 1, that means the event is certain to occur. It has to happen. Okay, it will occur no matter what here. Now, most probabilities kind of fall someplace in between there. For example, smack in the middle would be our 1/2. And in this case, I'm implying that the event is equally likely to occur or not occur. Now, certainly you could have a 1/3, a 1/4, a 1/8, whatever, anything that falls between 0 and 1. But keep in mind, the most you can have is a probability of 1. Now, sometimes we like to represent them as fractions, decimals, or percents. So again, if I just focus in on that 1/2, I could also say a probability of 0.5 if I wrote it as a decimal, or, I could say a 50%. So if I'm talking percent, obviously my greatest percent would be a 100% if it was certain to happen. Alright, so the probability that an event will occur, and we're going to use some probability notation. So I'm going to say the probability that an event will occur. So I'm just saying P of E. Probability the event will occur will be the number of outcomes in the event divided by the total number of outcomes. Alright, so it's kind of like a part over whole, or what you want to happen out of the total. Okay, so the number of outcomes in the event over the total amount of outcomes. Alright, so in our first example, we have a 6-sided die, which I think everybody can relate to if you've played a board game or something of that sort, or dice. You can picture a die. It has 6 sides on it, numbered 1 through 6. So find the probability that, let's say for A here, find the probability, so that's our capital P, that, let's say we want a 5. Alright, so very, very simple. Remember, the definition of probability is the number of ways it can happen over the total. So how many ways can you get a 5 when you roll a dice? Well, there's only one 5 on the die, so I'm going to say that's 1 out of the total number of sides, which would be 6. And there's my probability, 1/6. Now remember, you can write it as a fraction, decimal, or percent, but fraction's probably the easiest way. Letter B. Let's say we want the probability of an even number. Okay? Alright, so even number. How many even numbers? I've got the numbers 1, 2, 3, 4, 5, and 6. How many of them are even? Well, hopefully you're thinking 2, 4, and 6. So I would say that's 3 even numbers out of a total amount of numbers, 6. And of course we could reduce that to 1/2. The one they love to ask, probably the sneakiest there, is the probability of a prime number. Alright, so I might have to make you think back a little bit. A prime number. Can anybody come up with that? What is a prime number? And hopefully you've got something kind of burning in your brain. And perhaps we should write it down just to be sure. A prime number is a number that is only divisible by 1 and itself. Okay, only divisible by 1 in itself. So 6, let's start backwards. We'll start with 6. Well, 2 goes in there, 1 goes in there, 6, that is not prime. But 5 is only divisible by 1 and 5. 4 can be divided by 2, so that doesn't work. 3 is only divisible by 1 and 3. 2, that's the one everybody misses. 2 is actually only divisible by 1 and 2. And in fact, it's the only even prime number there is. Okay? It's a very special one. It's the only even prime number. And now 1, don't fall for that one. 1 is not prime. Even though it's only divisible by 1 in itself, it is not a prime number. So I would say that's a total of 3 primes out of 6, or again, a probability of 1/2. All right, so now I'm getting to everybody's favorite type of question. And you certainly don't need to copy this table down. I'm just putting it up there for students that don't play cards, I guess. The exam is going to expect you've used a deck of cards in your life and you kind of know what's in them. So again, I just wrote them out if you're not familiar. In a deck of cards, first of all, there are 52 cards in a deck of cards. And again, if I'm repeating things you know, good for you. And if you don't know them, maybe play some cards over Christmas break and learn the cards. You'll notice they're broken up into groups of 13. Okay, I have 13, and those are called suits. So I have 13 of each suit. I have 2 that are red, and then I have 2 that are black. They're called hearts and diamonds, spades and clubs, and then everybody goes ace through king. Now several cards have a face on them. Those are your jack, queen, and king. So those are referred to as face cards. So if you know your cards, you're in good shape. If you don't, it's time to practice those. All right, so question A. What is the probability of picking a red 7? Probability of a red 7. So remember, half the deck is red, so out of the 4 7s, 2 of them should be red. Out of all the cards, which is a total of 52. And of course, you could reduce that to 1 out of 26. Letter B. Let's say we want the probability of picking just a face card. All right, well, that's a jack, queen, and king. So that's 3 of them, and they're in all 4 suits. So 3 times 4 would be a total of 12 out of the 52 cards. And again, you could reduce that as well. All right, so here's where it gets a little more exciting. Hopefully, maybe you're thinking that was fairly simple, pretty straightforward. Maybe you did that in Algebra 1. Here's where it gets a little more exciting. We're going to use the word or. Okay, and this is a big term for us. So the probability of, we'll say, event A or event B. And here's how we're going to find that. We're going to get the probability of A, and we're going to add that to the probability of B. But then you have to subtract the probability, whoops, and it's not fitting very well, A and B. All right, so the probability that you've kind of already used one of those answers. So let me give you a couple examples here. Let's say the probability that you pick a queen or a red card. All right? So let me say that again. Probability you pick a queen or a red card. Box in that word or. That's got to trigger your mind here as this special formula. So the first thing I have to find is the probability of event A, which is the probability of a queen. And I'm going to add to that the probability of event B, my red card. And then I have to subtract out anything that repeats. Okay, so I'm going to subtract out the probability that I'm a red and queen. All right, so how many queens are in the deck? Remember, there's 1 in each suit, so that's 4 out of 52. Plus, how many red cards are in the deck? Well, half of the deck was red, so that's 26 out of 52. Minus, is there anybody that is a queen and is red? Have I doubled somebody up in here? Well, are there any red queens? Well, I think there are. There should be 2 of them. So I have to subtract out what I repeated, that 2 out of 52. So I've got my common denominator is 52, so that's good to go. 4 plus 26 is 30, minus 2 gets me 28 out of 52. Okay, so that word or, you find each one separately, and then you subtract anything that repeated. All right, second example here. The probability that you're a club or an ace. Okay, so box that word in or. There's your trigger word, club or ace. So let's start with the club. How many ways can you be a club in a deck of cards? Well, I believe you have 13 out of the 52 cards. Or means that add. How many ways can you pick an ace out of a deck of cards? Hopefully you've thought 4 out of 52. And now again, you're going to subtract anything that repeats. Are there any clubs that are aces? Clubs that are aces. Well, there is one ace of clubs, so I'm going to have to subtract him out. And I've got 13 plus 4 is 17, minus 1 is 16 out of 52. So, I don't know how we're feeling there. Remember, add each of those together and subtract anything that repeats. All right, letter C. Find the probability that you are a face card or an ace. So again, I'm boxing in that word or. That's my add symbol. All right, so how many ways can you be a face card? Remember, there's 3 face cards, Jack, Queen, King, on the 4 suits. So that's 12 out of 52. Or means add. How many ways can you be an ace? It's 4 out of 52. And I have to subtract out anything that repeats. Are there any face cards that are aces? Well, hopefully you're thinking no, because an ace doesn't have a face card. So basically I'm just taking nothing out. So I'm subtracting 0. So I get a total of 16 out of 52. All right, I'm going to switch gears on you now, and I want to focus on the word and. Okay, so that previous was or, where you add the 2 and subtract the repeat. Now I'm on and. So in this case, I'm going to do 2 things. I'm going to flip a coin and spin the spinner to my right here, or below. Okay, I'm going to flip a coin and spin the spinner. And notice my spinner is in red, green, and purple. So what is the probability that you flip and get a heads and land in green? Okay, and the probability that we flip a coin, get a heads, and land in green. All right, so I want a big star on your paper next to the word and. And when you see and, that is your trigger to multiply. Okay, we're not adding. Or was you add, multiply goes with the word and. So just ask yourself, how many ways when you flip a coin can you get a heads? Well, how many sides are in a coin? There's a total of 2 sides. One's a head and one's a tail. So I can only get a heads 1 out of 2 times. 1 head out of the 2 sides. And there's my multiply sign. How many ways can I be green? What percentage, so to speak, of the circle is green? I would say it's probably easy for me to break this into 4s. If I kind of go like that, and you can see that 1/4 of my spinner is green. So I would say on top, 1 times 1 is 1, 2 times 4 is 8. My probability is 1/8. Let's go ahead and try another. What is the probability that you get a tails and we'll say land in the red spot? Probability your tails and land in red. All right, so lots of self-talk here. Tails, when you flip that coin, how many sides are tails? 1 out of 2. And means to multiply. And red, if I look at my picture over here, I would say half of my spinner is red. So I'm going to say times 1/2. So I would get a total of 1/4. All right, a bag contains 2 blue, 3 green, and 4 red M&Ms. So I think this is something you can easily picture. And I'll draw it out real quick. So there's my bag. I've got 2 blue, 3 green, and 4 red M&Ms. So here's our probability question. That's that P again. The probability that you pick a red and a green with replacement. Now, what does with replacement mean? Well, basically, I'm going to pick an M&M, take it out, look at it, and put it back in. I'm going to replace it when I'm done looking at it. All right, so here we go. Let's start with red. What is the probability that you pick a red M&M? Well, it looks like there's a total of 4 reds out of 9 M&Ms possible. Okay, so again, total goes on the bottom. What you're looking for goes on top. Trigger word, and. And means to multiply. Okay. Now, remember, you took that M&M out, you put it back in the bag. So you still have a total of 9 M&Ms to choose from. And you want a green one this time, so I would say times 3/9. So I would say 4 times 3 is 12, 9 times 9 is 81. So a probability of 12 out of 81. Let's try another one. Let's say I want the probability, and let's just tweak it a little bit. Let's say red and green. And this time, let's say we just did with replacement. Let's do without replacement. So without replacement. All right, so that means after you first pick one M&M out, you are not putting it back in the bag. So think about that. If you had 9 M&Ms to begin with, you pull one out, and you don't put it back, how many do you have left? Well, hopefully you said 8. So let's set them up. I need the probability of being red. So if I look at my M&Ms, I had a total of 9 and 4 red ones to choose from. Trigger word and means to multiply. And now remember, without replacement, we can't put that red one back we took out. So, or whatever color it was. So instead of 9, I have a total of 8. And I'm looking for a green, so I have a probability of 3 out of 8. Multiply on top, 12 out of 72 now. All right, next question. So same bag of M&Ms, the probability that neither one is green. And I'm going to do this without replacement. All right, so if I'm saying neither is green, I do not want to see a green. So out of the 9 M&Ms, how many ways can you not get a green? Well, basically, I don't want a green, so I'm going to kill that. And I'm going to say I have a total of 6 out of 9 that are not green. Okay, so neither. So the first one's not green, and the second one is not green. So and is telling me to multiply. Now, do you still have 9? Did you put it back in the bag, or did you keep it out? Well, it said without replacement. So I don't have 9 anymore. I should have a total of 8. Okay. And if I'm not green, again, that's going to be a 6 out of 8 for a 36 out of 72. All right, let's try one more. The probability that you pick a blue and a red with replacement. So after you pick it, you look at it, you put it back. All right, so how many out of the 9 are going to be blue? Well, if I look, that's 2 out of the 9 are blue. And means to multiply. And remember, you put it back, so you still have 9 to choose from. And this time you're looking for a red, so that's 4 out of 9. So I would say a total of 8 out of 81. All right, folks, well, we've made it to the last problem. There's going to be a part A and part B, and this is probably the most popular exam question we've seen lately. All right, so take good notes on this one. Now, part A is going to look very similar to yesterday. A committee is to be made of 5 people. There are 8 women and 5 men. So part A, how many combinations are possible if 2 women and 3 men are chosen? All right, now it's just a combination, not a permutation. You're just going to pick people to be on this committee. So combination order doesn't matter. Let's start with the women. Oopsie. All right, we want 2 women out of a total of how many women do we have to choose from? Hopefully you said 8. So that's my 8C2. There's that keyword and. We said and means to multiply. And you want to choose 3 men. And you had a total of 5 men to choose from. So 5C3. And then at this point, this is exactly what we did yesterday. We'll just plug and chug in our calculator and we'll get ourselves an answer. I get 280. Okay, now I'm going to tweak the question just a little bit, and we're going to look for one key word that's going to change our setup. All right, so here it is. What is the probability that 2 women and 3 men are chosen? All right, so I want you to underline that word probability. This changes your setup just a little bit. And like I said, this has been the key exam question the past couple of years here. What is the probability that 2 women and 3 men are chosen? Now notice, it's almost the exact same question. I have the same numbers, 2 women, 3 men. The only thing I'm changing is from combinations to probability. And here's what has to stick out to you. Your answer for probability has to be a fraction, just like we've done the previous 10-15 minutes here. You've got to have a fraction. All right, so what I'm looking for is still going to go on top. I still have to choose 2 women and, there's my multiplying, 3 men. That's not changing. The total on the bottom is what's going to change. Remember, this is the total possible that goes on the bottom. Okay, now, all in all, in total, how many people do you have? Well, we had 8 women and 5 men. So I would say that's 13, and I'm choosing 5. All right, so I want you to think about this a minute. This is still what you're looking for goes on top. Okay, and the total amount of people go on the bottom. I want a total of 5 altogether, whether it's 3 men and 2 women, total of 5, out of the total of the 13 people. All right, and these numbers, I'm just going to box them in real quick. Notice how I keep saying total. These numbers should be this total, and the total that you want or that you're choosing should be this number here. Okay, so the only thing I'm tweaking is that word probability and making this a fraction. Now, I already know the top answer we calculated from before is 280 out of, I believe that's 1,287. All right, well, we did it. We've made it to the end. We look forward to seeing you tomorrow, and enjoy this last week of school. Make it count. Give it your all this week. Have a good night.